Assalamualaikum, my name is Abdullah bin Mudin with ID PH19026. Today I will present to you about the abstract. In this case study, we drew out four scope of study, which is Scope 1 General Information, Scope 2 Regional Tectonic Setting, Scope 3 Petroleum System Element, Scope 4 Petroleum System Process. For Scope 1, we know the location of the Green River located in United States of America and found in 1807 by John Colton. For Scope 2, the basin type for Green River Basin, known as Great Green River Basin, that from during Laramide. For Scope 3, exploration, resource evaluation and research is the practical application of the petroleum system. For Scope 4, we'll explain the process of generation, migration, and accumulation. All this for Scope.
My name is Chun King and metric ID TH19020. Our study is on Green River Field in the United States of America. In this video, I will present the location, field history, spacing type and age, and also the spacing sedimentary field. The Green River Field is located in western United States. The Greater Green River Basin in Green River Field is 21,000 square miles basin located in southwestern Wyoming, northeast Utah, and northwest Colorado as shown in the picture. The Greater Green River Basin is divided into four sub-basins, which are Green River Basin, Great Divide Basin, Wasatch Basin, and Sandwich Basin. In 1811 to 1812 years, the earlier exploration by Wilson Hunt in the Greater Green River Basin contained reference to the occurrence of fossil and coals. According to Kruger in 1968 years, gas was first discovered in the Greater Green River Basin in 1922 years in the Frontier and Dakota Formation and Southwestern Basin field on the Rock Spring Outlet. The last bare oil field was discovered in 1924 years and from tertiary sandstone. The Big Penny large field complex has produced gas since 1956 years and oil since 1960 years. Cumulative production by 1976 was 65 million barrels of oil and over 1.2 trillion cubic feet of gas. According to Wyoming State Geological Survey, the picture shows the cumulative production of oil and gas in Greater Green River Basin from 1978 years to 2018 years. The highest production of oil and gas was in 2010 years, which are 16.1 million barrels of oil and 1.4 trillion cubic feet of gas. According to U.S. Geological Survey, 1.45 trillion barrels of shale oil is estimated to be in place in the Eocene Green River Formation in the Greater Green River Basin. According to Ben, James, and Roberts in 1995 years, estimate of recovered gas in place is 119.5 trillion cubic feet. Based on the structural picture and the correlation chart of the Greater Green River Basin, the basin is a four-lane basin and formed during the Laramide erosion that began near the cross of the Cretaceous period. The Laramide erosion involved uplift in the mountain bordering the basin, plain crusting at the basin margin, local folding and normal faulting and rapid subsidence and basin deposition. The Greater Green River Basin is divided into four sub-basins by the Rock Spring Outlet. The picture on the right shows the regional stratigraphy of the Greater Green River Basin. According to Roger in 1992 years, the Greater Green River Basin has a thickness around 6,000 to 9,500 feet. The terrain is strongly influenced by the differential erosion of water and fog sedimentary rocks of Tertiary and Cretaceous age, and volcanic rocks of Quaternary age. That's all for me.
Assalamualaikum and very good day. I am Muhammad Saiful bin Omar Ali with ID number TH19023 of University Malaysia Pahang. So today I'm going to continue of our presentation. So my part is Petroleum System Elements in Green River, USA. So this is the content of my presentation, which is I will explain about source rock, reservoir rock, sill rock, and lastly overburden rock. Now we go to the first content, which is source rock. In general, source rock is oil generation place. So in Green River, potential source rock in the Osage Green River CTPS are primarily lacustrine deposit of organic rich shale, including oil shale and mudstone in the Green River Formation, and marginal lacustrine of terrestrial deposit of coal and carbonaceous strata in the Osage Formation, and to a lesser degree the Green River Formation. Lacustrine source rock contain type 1 and mixed type 1 and 3 kerogen in strata deposit in lake environments of varying water depth and salinities, which according to the Grabowski and Bohacz 1966, Carroll and Bohacz 2001. Coal and carbonaceous units in both formation contain type 3 kerogen. Carroll and Bohacz say 2001 grouped potential source rock in the Green River Formation in terms of 3 primary organic phases, which is the first is an algal terrestrial organic phases, the second is an algal organic phases, and lastly a fossilin algal organic phases. So the age of source rock is in between 49 until 55 million years ago. This is the example figure which show the cross section of lacustrine deposit. This is the age of this, and then we can see here this is the Green River basin, and then the blue one show the location of lacustrine source rock. Moving on to the next part, which is reservoir rock. In general, the meaning of reservoir rock is oil confirmed and stored. So in Green River, there are many types of reservoir in Green River, which is for formation reservoir rock. It includes Amsden, Linton, Morgan, Phosphoria, Reddick, Curtis, Sundance, and Mauritian formation. For sandstone, it includes Flathead, Darwin, Weber, Tinslip, Nugget, and Entrada sandstone. Other, it includes crystalline rocks, Bighorn, Dolomite, and Cinnamon member. So, published porosity and permeability value can be expressed in various ways. For example, as a single average value, as a range of value, or under segment. And the value are commonly noted as to sample type. For example, cuttings or core, and number of sample measured. In addition, many porosity and permeability value were determined from geophysical laws, according to the Edward A. Jones. This is the example figure. Show oil and gas field in Phosphoria total petroleum system of Western, Wyoming, province with reported sub-aqueous production. Then this is also the example figure. Show the schematic north-south showing depth to top of gas bearing over pressure strata and estimated depth to the 0.8% is reflectance RO horizon in the grid divine, HK and Sun was the scene. Southwestern Wyoming province, Wyoming, Colorado, and Utah. We go to the next part, which is sill rock. In general, its meaning of sill rock is oil contained in reservoir. So in Green River, organic rich lacustrine shale, including oil shale in Green River units such as the Wilkin Creek member, could also be considered as the primary reservoir for biogenic shale gas accumulation. Similar to coal bed gas, shale gas accumulation can include solvent gas on kerogen and clay particle surface, free gas in natural fracture, and intergranular pores, and gas dissolved in kerogen, bitumen, and water. Figures that are specific to reservoir lithology and physical characteristics of the accumulation are lacking. It is presumed that shale reservoirs are of low permeability and the natural fracture or well stimulation is critical for the productibility of gas. Evacuate, for example, Drona, which are interladen with some oil shale beds in certain area of the CTPS, as well as impermeable clay-rich units that are common in Green River rocks, might prompt effective seals. Fracture system, however, could limit the effectiveness of stratigraphic seal in fracture, prevent most of the stratigraphic section. This is the example figure. It shows the stratigraphic chart for the southwestern Wyoming province in Wyoming, Colorado, and moving on to the last part, which is overburden rock. In general, the meaning of overburden rock is rock that overlie the source rock, sill rock, and reservoir rock. In Green River, the deposition of the overburden rock is called the Green River coal. The thin, discontinuous nature of the coal bed could restrict reservoir and gas volume, and the fact that many of the coal beds are in close proximity to outcrops could result in gas leakage. Estimated for the percentage of the untested assessment unit area with the potential for addition to reserve are a minimum of 1%, a median of 6%, and a maximum of 15%. The minimum value represents potential related solely to the Vermilion Creek coal bed in the Vermilion Creek basin and include area where coal thickness generally range from 5 to 12 feet and overburden depth exceed about 200 feet.
Hi, Assalamualaikum. My name is Istiwan Hakim here. I will explain about Scope 4. Scope 4 is about trap formation. Trap formation for Green River Basin, USA, structural trap occur such as giant geological gas field where measuring this trap in the lands formation sandstone within Far 4 which Club 2004. Hydrocarbon production in the Greater Green River Basin is from conventional style structure and stratigraphic trap and the basin scanted gas system. Stratigraphic trap occur where sandstone bend pinch out up deep into less permeable rock. Area with the best potential for stratigraphic trap and structural deformation is different from structure control. This image shows contour map. For degeneration, accumulation, migration, currently no published evidence exists of long-distance hydrocarbon migration and accumulation history. Conventional reservoir sourced by the CPP unit described above. Because the greatest potential for hydrocarbon resource is CPPS is interpreted related primarily to biogenic gas generation, coal bed, and shale gas accumulation. This image shows cross-section showing stratigraphic limit of Grand River Formation, southwestern Wyoming Green River Basin. Event chronology for Greater Green River Basin, which indicate the favorable timing for accumulation of hydrocarbon generated from the oil shale source rock. The assessment unit is hypothetical and is interpreted to be biogenic shale gas oil source by volcanic ridge. Latest strata, including on shale, composed primarily by Corrigan.
For the conclusion of this case study, we can summarize there is two traps on Green River, that is stratigraphic and structural trap, which is form, process, migration, generation, and accumulation. That is already explained in Scope 2. That field throughout basin majority that produce natural gas. As we know, the Great River field have large amount of oil shale and fossil. The reservoir team should be able to minimize mistake on drilling process. To minimize the mistake and to increase the total amount oil and gas that can be drilled, the reservoir team should use the advanced drilling technique such as horizontal and multilateral drilling. The reservoir team also need advanced technology, for example, advanced WMD, which is measurement well drilling, and advanced mud solid control technology. This technology will help to ensure the availability of domestic natural gas in world for the future. That's all for me. Thank you.